Hi guys, good morning and welcome to Pankaj's Echelon tutorials once again. And this is the continuation of the video that I started with in the last video. I started with this, you can see on the screen. I started with this IGCSE physics, okay, and I had started with this chapter properties of waves, okay, and I'm referring to this Davidson book, okay, the physics course book. And I had started with this chapter, and in the nutshell, these were the points which I had discussed last time. And out of these points, actually wave and its description and the terms and the terminology of the wave, these two parts, these two things, I have already discussed in the previous video. So this is a continuation of that previous video. This is video number 2 of properties of waves. So here today I am going to discuss numericals, okay, on this terms and terminology of the wave that we have studied. On that, there are certain numericals based and certain problems based, okay. So that I am going to discuss today, and thereafter I'll go to the types of waves, okay. So in this today's session, we are going to start with certain numericals or certain problems, okay, related to this terminology of the wave. Now, if you remember in the last video, in the terminology, I had mentioned about the wavelength, then I had mentioned about the frequency, I had mentioned about the time period, the speed of the wave, etc. Okay, these are the various properties, the basic properties of any wave, okay. But then somehow I skipped one property last time, and that the name of that property happens to be amplitude, okay. So today I'm going to just brush up all these properties once again before you, and then I'll come down to the numericals, okay. So here we go. So this is in general a wave, okay. And in the last video, I had mentioned about what is a crest, what is a trough. Now you can see here this particular region of a wave is known as a crest, okay. This is a crest, this is a trough, and this length, from here to here, this is the wavelength, isn't it? So crest, trough, wavelength, all this we had discussed. Only thing that I had skipped or I missed was the amplitude. So today I'm going to tell you what is amplitude. So amplitude is what, okay. Amplitude is generally denoted by a capital A, okay. And this amplitude is nothing but I'll show you on this wave this particular distance of the peak from the line of equilibrium, okay. This distance is known as amplitude, okay. For that matter, even this will be amplitude, okay. This distance is amplitude denoted by a capital A. So what is amplitude? Amplitude is the definition of amplitude goes this way. It is the maximum displacement of a particle from the mean position. This is one way of defining, but if this is not clear, this definition is not clear, we can go for second one, okay. The second says that amplitude is, it is the maximum you can say distance reached by a wave, okay. I'll write wave peak, okay, from the undisturbed state of the wave. Now this is also a very good definition of amplitude. This is the distance traveled by the peak, or the distance which is reached by the peak. The peak is nothing but a crest. Trough can also be called as a peak, but that is in the negative direction, in the downward direction, okay. So the distance that is reached by the wave peak from the undisturbed state of the wave. Now this horizontal line is representing your undisturbed state of a wave, okay. So even this definition will work. So this is the definition of amplitude. Rest of the definitions we have already talked about. Okay, and the SI unit of this amplitude should be like anything from meter, centimeter, millimeter. So it's a length. So any distance, any unit of length will be sufficient for this amplitude. Okay. So that was regarding amplitude. Now that we have discussed all the this is something which I had skipped last time. So now that you are handy with all the terms, let us just summarize all the terms. Okay. So let me summarize all the properties. Okay. So to summarize all the properties, we have learned number one, the wavelength, which is denoted by a lambda. Then second was frequency, which is denoted by a f. Okay. Then third was something called amplitude that we just now discussed. Amplitude denoted by a capital A. Fourth is a period, okay, which is denoted by a capital T. Wavelength, frequency, amplitude, period. And fifth was uh, the speed of the wave. Okay. So wavelength, frequency, amplitude, period, and speed of the wave. These are the five basic properties of any wave. Now we also studied that there are certain relationship between the some of the properties. Okay. So the relationship that you should remember, number one, is that your time period t is equal to 1 upon frequency. Okay. T is equal to 1 upon f. Now, this is one relationship that you should remember because you are going to use that in the numericals. Second is the speed or the velocity of the sound is equal to lambda times the frequency. Okay, this this is also a relationship very useful. Okay, velocity of a any wave is equal to the product of its wavelength and its frequency. Okay, so these are the two relationship which is very important in this context, and two more points, okay, of concepts are very important at this stage. Let me tell you these 2 points as well. Okay, these 2 points are: number one, wave carries only energy, not the matter. Okay, this is very important. The wave will carry only energy from one place to another place, but it will not carry the matter along with it. Okay. Second thing you should understand is when a wave is traveling from, say, a less denser medium to a denser medium. Okay, then what happens, the speed of the wave is changing. Okay, so this you can represent this way. Suppose a wave is traveling now, your third relationship is your lambda is directly proportional to the velocity. Okay, so this is also very important. Lambda is directly proportional to the velocity. Okay, so if the velocity of the this thing wave is more, the lambda is also more, the wavelength is also more. Okay, and fourth relationship is lambda and frequency are inversely related. Okay, they are inversely related. So see, this is inverse proportion. This is not equal to 1 by f. Okay. The lambda and frequency are inversely proportional, means when lambda increases, the frequency decreases. When lambda decreases, the frequency increases. That is the relation, proportionality. Okay. It's not equal to. Okay. Equal to is between T and F. Right? Okay. So these all relationships are very important. Apart from this one concept was very important, you should remember that. Second concept is whenever a wave is traveling from a rarer to a denser medium, okay, what happens is the the velocity of that wave, is changing. Okay. Now, to demonstrate that, I will tell you when the what happens when I say that the medium is changing from rarer to denser medium. Okay, that means the material is changing. See, different material you can call as different medium. Okay, so when the medium is changing, you can refer to as the medium is changing means the material is changing, one and the same. Okay, so from one material to another material, when the ray travels, there is always a change in the speed of that wave. Okay, so suppose a wave is traveling, say, from water to glass. Now these are two different materials, water to glass. Water is comparatively having less density and glass is having more density comparatively. Between comparison of water and glass, density of water is less and density of glass is more. So what happens is, whenever a transverse wave is traveling, okay, from water to glass, what happens is the speed of that the speed of that wave is reduced. Okay, so when the speed of the wave is reduced means we can say that the velocity is reducing. Now velocity is directly proportional to the lambda. So can I draw the diagram this way? Suppose this is the wave. Okay, now this is when it was in water. Okay, can you see the wavelength is this much? Okay, this is the wavelength. Now when it enters into glass, what happens is the wavelength decreases. Can you see this wavelength has decreased? Okay, so suppose this was say 10 centimeter, so this is probably 5 centimeter. Okay, half the wavelength is reduced by half. Okay, so 10 centimeter became 5 centimeter, or in other words you can say that the velocity has decreased. Now I told you when the lambda is more, velocity is more. So here lambda is more, so velocity will also be more. So here the velocity will be less. Okay, so whenever a transverse wave is traveling from a rarer medium, now this is known as a rarer medium. The density of a medium is less, means it is a rarer medium. When the density of a medium is more, that means it is a denser medium. Okay, when the density is less, it is a rarer medium. Okay, so this can be called as a rarer medium, this can be called as a denser medium. Now these are the things which you should understand before we jump into the numericals. Okay, so now the next step is to jump into the numericals. Okay, so we will be solving some numericals pertaining to this terms and terminology that we have studied. Okay, so let us move on to the numericals. Now this is the very first numerical that we are going to work out. Okay, and this is from your textbook only. So this particular numerical, okay, first try to understand what the numerical has to say. Okay, and if you solve this numerical, if you solve this problem, automatically your concepts of this properties of the wave will become very clear. Okay, so let us try to solve this numerical. Okay, now this numerical is pertaining to this diagram. Can you see this diagram? Okay, let me take this diagram. One second. Okay, because we are going to use this diagram, right? Fine. Now I have extracted this diagram over here. Let's zoom it. Okay, fine. Now if you want, I will reduce this now, because all the writing work I can do for you. Okay, okay. So coming to this particular numerical. Now here you can see uh, in this particular diagram. Can you see this diagram? Okay, this one. Okay, now this thing which is which you can see Okay, this is known as a uh, pier, P-I-E-R. Okay, what is it known as? It is known as a pier, P-I-E-R. Okay, what is a pier? It is a small extension of a bridge into the sea. Okay, maybe for observation or maybe whatever it is, but it is kind of a platform which is entering into the sea, and it is not very long, but it's made for some purpose. So it is known as a pier. Okay, now this pyre you can see, this is shown, and you can see the waves over here. Okay, so it is, the pyre is always made on the sea, isn't it? So this pyre, the question says that this pyre is 60-meter long. Okay, the length of this pyre from year to year, okay, it is 60 meters. So I'll write here length of the pyre is 60 meters, right? So maybe from this point, okay, to this point, okay, this is the length of the pipe, that is 60 meter, that is given. And he says that uh, there are some 5 waves to be seen along this pyre. Okay, how many waves? 5 waves. Okay, so he says that 5 waves, 5 number of waves can fit in this pyre. It is given it can fit. Okay, so in this 60-meter length of the pyre, there are some 5 waves. Now can you see, this is one wave. Okay, this is 2, 3, 4 and 5. You can just see the peaks. Okay, so if you happen to see the peaks, okay, you will be able to see 5 peaks. Okay, so you'll be able to see 5 peaks. Okay, so 5 peaks can be seen over here. This is 1, 2, 3, 4 and 5 peaks. Okay, so 5 peaks represent that there are 5 number of waves between this starting point and the end point of the pyre, that is within the 60-meter pyre. Okay, now he is asking you to find out the wavelength of this waves, wavelength of the wave. Okay, that he is asking you. Now how we are going to find out the wavelength? Now I will demonstrate here so that you understand it very nicely. Now suppose this is 60 meters kapaya, and you have some 5 peaks. Okay, so this will be 1 peak, 2 peak, 3 peak, 4 peak and 5 peak. Okay, so you can see that from year to year this is one wave, so one wavelength, I'm sorry, from year to year. Okay, this is one wave. Yeah, I'll draw that again for you. So wave starts from this point A. Okay, this is one wave. Okay, this is two, this is one, this is two, then this is three, this is four, and then this is five. Okay, I'll extend this a little bit. Okay, so can you see those 3, 4 and 5? So these are the 5 waves. Now what is wavelength? Wavelength is nothing but the distance between two consecutive crests. According to definition, it is distance between the two consecutive crests. This is C1 and C2. Okay, so but instead of that, we can take this also as the wavelength. I told you that the distance from A to this point B is also wavelength. Okay, now if you see carefully, this entire distance of 60 meter has how many wavelength? It has 5 wavelength. Okay, because there are 5 waves. Okay, so 60 meters divided by 5 will give you the lambda, that is the wavelength, isn't it? So 60 divided by 5 happens to be 12 meter. So your lambda is nothing but 12 meter. Okay, so the wavelength of this particular wave is 12 meter. Is that clear? Now let us see what next he has asked you to find out. Now he is telling you that the speed of the wave is how much. Okay, speed is how much. and for that he is telling you that from the end of the peak, okay, that is this point, okay, this point, let me go back to the diagram, okay, from this point, here, it takes 4 seconds for a wave, for a crest to pass, okay, for this crest to pass from this point, it takes 4 seconds. So this 4 seconds represents what, see, when a one crest is passing through a point, that means one wave is passing through a point, and when one wave is passing through a point in 4 seconds, then obviously that 4 second will be nothing but the time period, okay. So he is saying in the question that a crest takes 4 seconds to pass through the end point of the pyre, okay. This implies that your t is equal to 4 seconds, isn't it? Now speed has been asked to you. So speed ka formula I told you, velocity is equal to lambda times your frequency, isn't it? This is the formula, right? So using this formula, we know lambda is 12. So V will be equal to 12 times frequency. Now we don't know what is frequency at this stage. But then I told you there is a relationship that frequency is equal to 1 upon T. Using that, T being 4, your frequency will be 1 upon 4. Okay. And 1 upon 4 will be in hertz. The unit will be hertz. So can I take 12 into 1 upon 4 as the frequency? And this works out to 3. So 3 meter per second happens to be the velocity of this wave. Okay. So velocity of the wave also you have calculated. Now he is telling you that verify whether this formula V is equal to lambda into F is valid or not. Now obviously it is valid because using this formula only we have found out the velocity, isn't it? Or in otherwise you can do this way also. Velocity is equal to lambda into F can be written as 1 by T. Okay, because we know the relationship of F and T. So instead of F I can write 1 by T. So V will be equal to lambda divided by T. Now lambda was 12 meter, isn't it? And T was 4 seconds, right? So this also gives me the answer as 4 upon 12 upon 4 is 3 meter per second. So see, we are getting the velocity as 3 meter per second. So this formula is perfectly valid, or it is satisfied, okay. So this was that one numerical that I wanted to solve. Now I want to solve two more examples in front of you, okay, the solved examples. So this is one solved example, okay, let us solve that, okay. So it's a worked example, but we are going to just discuss it, okay. Sorry. So let me take this example on one side. Okay, now let us work this example. Now what this example says is uh, uh, okay, let me read out from the book. It says that a FM radio station broadcasts signals of wavelength 1.5 meter. This is that example we are doing, okay. This one, right? So it says that a FM radio signal, FM radio station is broadcasting a signal whose wavelength is 1.5 meters, right? And the frequency of this particular signal is 200 megahertz. Okay. What is the speed? So what is the velocity of this wave? This is the question. Okay. So again, very simple. You have to use this formula. V is equal to lambda into F. Lambda is given to you as 1.5 and frequency is given to you as 200 megahertz. Megahertz means 200 mega means 10 raised to 6. So it will be 200 into 10 raised to 6 hertz. Okay. Now this will work out to 1.5 into, this can be written as 2 times 10 raised to 8. Okay. And this 1.5 into 2 will work out to 3. So 3 into 10 raised to 8 meter per second. This is the velocity or the speed of the signal. Is that clear? So velocity of the signal we have worked out. It is 3 into 10 raised to 8 meter per second. Okay. Now let us try to work out one more example. Okay, from this book, and that is this one. Yeah, all these things from the previous video. Okay, uh, let me just delete all this. Fine. So we are left with this question now. Okay. Okay, let us work out this question. Now what this question says is, this is the second example, and it says that a pianist plays the note, uh, plays the note middle. What is this? A pianist. What is this? 14.2, no? The highest note. Oh, what is this? There's something here. There's something here. Okay. Okay. Now there's some ambiguity here. This is actually in my textbook. It is given this way. The highest note on a piano has a frequency. So I don't know how this has come. Right. The highest note on a piano has a frequency of uh, okay, this is some other question. Okay, so let me not do this question, because I have another question for you. Yeah, so this is that question I'm writing for you. Okay, this example, right? The highest note on a piano has a frequency of 4, 1, 8 and a 6 hertz. Okay, and then he says, what is the wavelength of the sound? What is the wavelength of the sound waves, okay, produced when this note is played? Okay, assume that the speed of the sound in air, so velocity of sound in air, you have to assume it to be 330 meter per second. Okay, so and give your answer correct to 2SF, two significant figure. Okay, so that's the question. The highest note on a piano has a frequency of 4186 hertz. So your lambda is what is the wavelength that you have to find out? Your frequency is given as 4186 hertz. Okay, lambda is something which you have to find out, the wavelength of the wave sound produced. What is the wavelength of the sound produced? So that you have to find out. And velocity v you can take as 330. Okay, so using this relationship v is equal to f lambda, we can write down that 330 is equal to 4186 times lambda. So 330 upon a 4186 will give you lambda. Now if you plug these values in your calci, you may get answer like something like uh, 0.07166. Okay, so this is the answer, but then the answer you have to give correct to 2SF. 2SF means what? Now here 0.07166, this is the number. In this is first significant figure 7, and this one is the second significant figure. So you have to give the answer only till this 2SF. Okay, so your answer will be 0.07. Now this 1, whether it will remain 1 or whether it will get converted to 2 depends upon what is the following number, that is after this dotted line, what is the number. So after the dotted line you can see that there is a 6. Okay, and if this number is 5 or greater than 5, then you have to make this 1, you have to increase by 1, that is you have to make it 2. Okay, so this because this number is 6, I'll make it 2. So 0.072 meters is the answer for the wavelength of this particular wave. Okay, so with this, some of the numericals I have already solved in this today's video. In the next session I will definitely start with the different types of waves. Okay, so there I will be discussing the various classification of wave. Okay, so whether a wave is a transverse or a longitudinal wave, and what are the properties, what are the similarities and difference between these two types of waves. We'll be talking about mechanical waves and the electromagnetic waves also, and after that we'll be coming back to the ripple tank, and there we are going to study how the formation of the ripple changes when there's a reflection taking place, when there's a refraction taking place. So all this we are going to cover in the subsequent sessions. So for today that's all, and I hope you must have liked this session, and if you happen to like this session, please subscribe my channel and encourage me to make more beautiful videos. So thank you very much for being with me. Bye.